Good morning, students. In previous class, what about that hydrogen spectrum, different types of spectrum, all those things we have seen. Okay. In today's class, we will go through what about the next concept, that is quantum numbers now. Before going to quantum numbers, I will give small information about shells. What about the subshells, orbitals, all those things I will give data. Okay. After that, we will go through quantum numbers. Let us see what about that. This is the nucleus we have. According to Niels Bohr atomic model, positive charge of the atom is present at the center, which is called nucleus. Okay, electrons are revolving around the nucleus in different orbits. Okay, now this is first orbit, n is equal to 1. This is second orbit, n is equal to 2. This is third orbit, n is equal to 3. Next, fourth, n is equal to 4, n is equal to 5. Like that up to 5. Up to 5 shells I took example now. Okay, now let us consider these main shells or orbits are like floors. Suppose our school is there. Okay, our school contains different floors. Let us consider first floor, second floor, third floor, fourth floor, fifth floor. Like that 5 floors building. Once again, first floor, second floor, third floor, fourth floor and fifth floor. Okay, now how to remember this easily? Totally we have 4 important levels. Those are shells. First one, shells. These are all shells. Second one, subshells. Third one, orbitals. Fourth one, electrons. Electrons. Observe the 4 levels now. What are those 4 levels? Shells, subshells, orbitals, electrons. Okay, now n is equal to 1, n is equal to 2, 3, 4, 5. These are all shells. In shells, we have subshells. In subshells, we have orbitals. Finally, in orbitals, we have electrons. That is the order. For example, 5-floor building is there. First floor has 1 room. Second floor has 2 rooms. Third floor has 3 rooms. Okay, those rooms are called subshells. Those rooms are called subshells. In those rooms, again we have benches. Those are orbitals. In those rooms, again we have benches. Those are orbitals. In those benches, we have students. Those are electrons. Okay. Now, once again I will repeat this one. Just observe one of you. I gave the example on board, that is n is equal to 1, 2, 3, 4, 5, etc. Okay, up to 5 I took ma. Those n is equal to 1, 2, 3, 4, 5 are all shells. Okay, now remember carefully. N is equal to 1 shell has 1 subshell. N is equal to 1 shell has 1 subshell. n is equal to 2 shell has 2 subshells. That one also I will write on board. Okay. N is equal to 3 shell, third shell has 3 subshells. Fourth shell has 4 subshells. Fifth shell has 5 subshells. So what is the number? That number is equal to number of subshells. Okay, now let us consider. Please observe carefully, all of you. N is equal to 1. This is shell. Has 1 subshell. That is S. Name of that subshell is S. Next. N is equal to 2. Second shell has 2 subshells. Those are S comma P. Next. N is equal to 3 has 3 subshells. This is N is equal to 3 shell. Okay, has 3 subshells. Those are S, P, B. Next. N is equal to 4 has 4 subshells. Those are S, P, D, F. First shells, next subshells. After that we have to see orbitals. Before that, write this one in notes clearly. Okay, N is equal to 1 has 1 subshell, that is S. N is equal to 2 has 2 subshells, S comma P. N is equal to 3 has 3 subshells, S, P, D. N is equal to 4 has 4 subshells, S, P, D, F. Okay, everywhere S, SP, SPD, this S is getting repeated. From here P is getting repeated. From here D is repeated. Okay, ma? But what is the difference between this S and this S? If you get the doubt like that, this is belonging to which shell? First shell. So this is 1S. This S is nothing but 1S. This S is belonging to which shell? Second. So this is 2S. This is also 2P. Both are belonging to second shell only. That's why 2S comma 2P. Next. N is equal to 3 has 3 subshells. SPD. These are all belonging to third shell. So 3S, 3P, 3D. These are belonging to fourth shell. So 4S, 4P, 4D, 4F. Till now, we got the data about only subshells. Okay, observe all of you. Okay, N is equal to 1 has 1 subshell. N is equal to 2 has 2 subshells. N is equal to 3 has 3 subshells. N is equal to 4 has 4 subshells. Okay, and what about them? 1S, 2S, 2P, 3S, 3P, 3D, 4S, 4P, 4D, 4F. Okay, next we have to enter into orbitals. We have to enter into orbitals. Okay, ma? Shall I go through? shells, subshells, opposite orbitals. Now S subshell has one orbital. S subshell has one orbital. That S might be 1s, 2s, 3s or 4s, whatever it is. It has only one orbital. What is the name? 1s only. Why? For example, 10th class has one section. 10th class has one section. What is the section name? 10th section. Because no further number of sections are there, only one section. If it is only one section, no need to give A or B, X and Y, like that, no need to give names. Correct or not? Are you understanding, ma? If you have only one section in 10th class or any other section, okay, definitely no need to give name. Simply we will say 10th section, 12th class, like that we will say. But we won't say section name. When we will get section names, if you have at least two sections, then we will give 10th A, 10th B, like that. Correct? Like that here also. S subshell has only one orbital. So what is the subshell? 1s subshell, 1s orbital. 2s subshell has 2s orbital itself. The 10th class contains one section. That section is nothing but class only. Like that. 1s subshell has one orbital. So whatever the S might be, whatever the S subshell, it has one orbital. Okay, next. 1 second, ma'am. Whatever the P subshell, P subshell has three orbitals. P subshell has three orbitals. Those are Px, Py, Pz. Px, Py, Pz. Next. D subshell has 5 orbitals. Any D, that is 3D or 4D, 3D has 5 orbitals, 4D has 5 orbitals. Okay, names dxy, dyz, dxz, dx square, y square, dz square. Till D subshell it is enough, ma. F subshell has 7 orbitals are there, but names we don't know. Means scientists also could not give that one because of their shapes are not known. Okay, so after completion of this, I will give the shapes of all these orbitals. S orbital, 3p orbitals, D orbitals, 5. Okay, so whatever it is written on board, observe carefully. Once again. N is equal to 1 has one subshell. N is equal to 2 has two subshells. N is equal to 3 has 3 subshells. N is equal to 4 has 4 subshells. Okay. Now again coming to subshell. Okay. S subshell has 1 orbital. P subshell has 3 orbitals. D subshell has 5 orbitals. Okay. Now once I will write clearly on the board. Okay, ma. Before that, note down the data clearly. Now I am going to run this one. See, n is equal to 1. This is shell. Contains one subshell. What is that? 1s. Okay. One subshell has one orbital, that is also 1s. This is about n is equal to 1 data. So n is equal to 1 has how many orbitals? 1 orbital. Okay. Next, n is equal to 2 shell. N is equal to 2 means this is K, this is L shell. Okay. Has two subshells. Those two subshells are 2s, 2p. These two are subshells. Again 2s has one orbital. One orbital name is 2s. 2p has three orbitals. 2p has three orbitals. Those are, this is second shell, so 2px, 2py, 2pz. This is the data about first shell. This is the data about second shell. Next, third shell I will give. N is equal to 3. M shell. Now n is equal to 3 has 3 subshells. What are those 3 subshells? 3s, 3p, 3d. 3s has one orbital, that is 3s. 3p has three orbitals. Those are 3px. Previously these are belonging to second shell, so 2px, 2py, 2pz we got. Now 3px, 3py, 3pz. 3d has 5. 1, 2, 3, 4, 5. 5 orbitals. What are the names? 3dxy, 3dyz, 3dxz, 3dx square y square, 3dz square. This is the information about third shell. So neatly note down that one carefully, all of you. So after completion of this, we have to keep the side heading, that is shades of orbitals. Keep the side heading, all of you. Shades of orbitals. First, S orbital. S orbital shape is spherical. Actually, this is three-dimensional. It is like a sphere, ball. Okay, three-dimensional. Z-axis must be like this. It is not possible to draw on board. That's why I am drawing like this. X-axis, Y-axis, Z-axis. We have to mention the axis clearly. Okay, this is the shape of S orbital. In this, electron might be present everywhere, anywhere. Like a wave, it is revolving around the nucleus. After this, next d orbitals. P orbital shape is dumbbell. Three are there, na? Px, Py, Pz. This is x-axis. Otherwise, do one thing. This is x-axis. Like this. This is the shape. This is y-axis. Okay, next. X, Y, along y-axis. And third one, z-axis. This is Z. This is PZ mark. This is PY. Sorry, this is PX. These are the three shapes of p orbitals: Px, Py, Pz. You will get more clear after writing the electronic configuration, no problem. Before that, till now what is the thing I told? Concentrate on that one clearly. Okay, ma? Next. D orbitals. D orbital shape name double dumbbell. Total 5 are there. Okay, see. This is x-axis. This is y-axis. This is a dxy. Name of this orbital is dxy. Next. This is Z, this is Y. If it is Y and Z, X will be like this. That is total reference only, no problem. The three axes must be perpendicular to each other. Okay? DYZ. And next one. This is X, this is Z. This is dxz. Next, this is x, this is y, along the axis. This is dx square y square. This is along the axis, this is in between the axis. This is x square y square. Pronunciation is dx square y square. Please don't pronounce it as dx square minus y square or dx square 2y square, like that. No need. Simply dx square y square. And fifth one, only z axis. Some x might be there, or it will be anyways. This is dz square. This is like down at ma. See, this is the orbital. This is looking like this in the middle. You know donut. The donut like this and like this. That is dz square. F orbital shapes we don't know because even scientists couldn't find them. They are highly fused. Means no one can draw that one because highly complicated. This one itself three-dimensionally we have to observe. Okay, so these are the up to D. It is enough. All of you draw the shapes of orbitals clearly. Now finally, one question. Whether you are clear or not, you can say ma. N is equal to 1 has how many subshells? 1 subshell. N is equal to 2 has 2 subshells. N is equal to 3 has 3 subshells. N is equal to 4 has 4 subshells. N is equal to 1 has 1 subshell, that name is 1s. N is equal to 2 has 2 subshells, 2s, 2p. Okay, next. N is equal to 3 has 3 subshells, 3s, 3p, 3d. All are belonging to 3 na, so 3s, 3p, 3d. We have to remember the order S, P, D, F. First shell S only, second shell S, P, third shell S, P, D, fourth shell S, P, D, F. According to shell wise, we will give the name number. Okay, ma? After that, orbitals numbers. S has only 1 orbital, P has 3 orbitals, D has 5 orbitals, odd numbers you can remember. Okay, F has 7 orbitals. Shapes of orbitals up to D we have seen today. Okay, in the next class we will see quantum numbers. Okay, please try to understand the concept clearly, love you. Okay, each orbital can accommodate 2 electrons. Each orbital can accommodate maximum 2 electrons, minimum 1 electron. Okay, next in quantum numbers and electronic configuration you will get more clear data about this electronic arrangement. Okay, thank you all.